Can you hear me?
Yes, can hear you, sir.
Yes, sir.
All right, thank you very much. Just wanted to confirm that I'm not talking to myself. All right, today, sorry about yesterday because it was a public holiday. I also do not want to go against the norm to get you online during a public holiday. But never mind, we will have a session on Tuesday, so we can make use of this good session for our to replace what we miss out on Monday. Okay, let me share my stuff. All right, so today we're going to talk about, again, data link layer. And data link layer has got multiple functions. It's actually quite a complicated layer. This layer carry out a lot of functionality. As we all know, say from the physical layer is all about signaling. Signaling means electrical signal carrying your data 1 and 0. So we have been talking about in physical layer, we have, we are using electrical signal to represent 1 and 0. So that is actually the role of the physical layer. But now, when this physical layer be able to deliver all your 1 and 0 from one end to another end, then it will going to be passed up to the data link layer. So what is the function of this data link layer here? One of the important functionality of this data link layer is actually on the error detection and error correction. Because we all know that when you actually transmit data over a transmission medium, then this data is subject to a lot of interference. And the problem with this interference is that it is going to disturb your signal. Once the signal is being disturbed, so the representation of 1 and 0 will be changed, you see. So your data will have errors, you see. So those kind of things we cannot avoid. It's very difficult for us to actually avoid that kind of errors. But what we can do here is actually to detect the error, and then we try to correct it. We try to correct the error. And then the first level to do error detection and error correction is actually at layer 2. Of course, at higher layer, we have 7 layers, isn't it? So at higher layers, this error detection and error correction can also be handled by the upper layer, but using a slightly different technique. But today we are going to talk about all the technique that's being used for error detection as well as for error correction at the data link layer, which is layer number 2. Okay, let's move on. So today we're going to talk about just study a little bit more about what are the different functionality of data link layers. Our learning unit number 8 and learning unit number 9 is going to talk specifically on all the functionality of data link layer. And of course, for this learning unit number 8, we focus on error detection and error correction, how error is being detected. This is mean detected at the receiver end, So receiver will detect the error, not the sender. The sender would not know, you see. The sender would not know that when an error is actually occurring. The sender will just send. So when your data going through a transmission medium, so when this data arrive at the destination, then that is the point where you're going to detect the error. And if your end station is actually more sophisticated, then they can even have the ability to correct the error, right? So today we're going to talk about some of the technique that we are going to, how error are being detected, mainly through the redundancy that is being append together with your data that is to be sent to the receiver. And also how do we use those redundancy data to perform error corrections. So when we can correct the error, then we do not need to ask the sender to resend again. Detecting and correcting is 2 different things, You can detect and telling that there are errors. So what you can do when you discover errors, you can always ask the sender, hey, the thing that you sent me got errors. Can you send me again? This is a simple thing that you can ask. But if the receiver has more sophisticated algorithm, then they will have the ability to correct the error without asking the sender to resend the same data again. So that is what we call the error corrections. So there are different techniques. In fact, what we're going to talk about here is some of the very basic technique that is being used in, this is entry level, I would say, entry level type of error detection technique as well as error correction techniques. Of course, there are a lot more others which are much more sophisticated one that you will, if you are interested, you can always discover more after this. And again, look at the data link layer, just a reminder that, at the data link layer, which is 1 layer higher than the physical layer. So the moment when you receive data, the 1 and 0 coming from the physical layer, so this is what the data link layer is going to carry out. So we're going to look at the different functionality. And if you look at this diagram here, you are going to see that at data link layer, they actually carry out 5 main functions. One is packetizing. Okay, it's the way you organize your packets, and addressing as well. Your data packet will start to have an address in this layer. And of course, you look at flow control. Flow control meaning to say that, the sender and receiver, how fast can you send? Whether can you send at 10 megabit per second, 100 megabit per second. So those are fall under the flow control. And of course, media access control. Media access control means sharing. So everyone is sharing the same physical layer. So now whose turn to actually use the physical layer? Because this is network is all share, isn't it? We want to save cost. So network is actually sharing the media. So media access control is a mechanism to decide now is whose turn to actually use the transmission media. And lastly, which is actually what we're going to talk about today, is actually the error control. So how do we control the amount of error that occurs in our network? Mainly coming from the physical layers. The moment when physical layer do not have the ability to correct. They can only guess. The moment when physical layer, experience interference, so at the receiver end, when they try to translate from electrical signal to 1 and 0, what they can do is only do their best guessing whether this is a 0 or this is a 1, right? So if they actually did the wrong guessing, so you're going to have errors in your data. So, and then this data with error is going to pass up to your data link layer, and your data link layer mechanism, such as the error control mechanism, is going to deal with that errors. It's either try to detect it and then drop it, ask the sender to resend again, or if your data link layer's algorithm is more sophisticated, then you will be able to correct the error. Okay, so these are actually some of the functions, as I mentioned just now. Same thing, some of the functions we're going to discuss in our next learning unit. But today we're going to focus just on the error control. So these are the things that I've been talking about. What are the function and the duty of the data link layer? Packetizing is you have to group your packets, when you actually send them, you don't send them one by one, is it? Because if you send them one by one, it's very hard for you to identify them. It's very hard for you to actually manage them. So the best way is to group them, right? So the best way is to group them and then give them an address. Give each of the group of the data packets an address so that it will be easier for management. If you're going to send one by one, then each of these is going to have an address, which is very difficult for you to do that. It's not efficient, actually. That's why starting from layer 2, your data is being organized in such a way that you will be packetizing all your data, and you will give each of the packets. Here we still call it packets. I know in layer 2 here you have a different name for data packetings, but we still call it a packet. I know it's confusing. Usually we call it a frame in layer 2. So each of the frame we will have an address. And this address is what we call the MAC address. We're going to talk about it in our next learning unit. And error control, again, this is what we're going to talk about in more detail. And flow control is about, when you send and when you receive. So if you have a fast sender and a slow receiver, so you are a fast sender, you have to accommodate to your slow receiver so that both of you can talk at the same pace. So not one talking too fast and the other one cannot catch it. There's no point. That's why you need to have this flow control. So if you have actually both receiver and sender are actually fast, then you can transmit at very high speed. But let's say if one of the receiver is very slow, so the sender, even though they can do very fast sending, but they have to slow down as well. This is what we call the flow control, to make sure you don't send too fast until your receiver cannot actually receive it properly. And lastly, medium access control, as mentioned, is a share medium. And how do you share? Is it based on round robin, or is it based on first come first serve, or whatever? This one you can always imagine. I always like to use the example of a public toilet. You go to public toilet, how are you going to share the toilet? You see, are you going to queue? Are you going to say that I'm a VIP, I have to go first? Things like that. So this is medium access control. Right. So let's look at error detection. So we're going to look at the type of errors that we are having, and redundancy, detection versus correction. What is the difference between detection and correction? And what is forward error correction versus retransmission? And we're going to look at some of this modular arithmetic. Right. So one of the facts that we cannot deny is that when you send a data across a transmission medium, your data will always get corrupted, or depending on what type of transmission media. If you are sending using a wireless transmission medium, obviously the amount of error that you are going to encounter is going to be much more as compared to if you are using a fiber optic. If you're using a fiber optic to send your data, so your error rate is going to be very low. That's why it's much more reliable if you are using a cable medium, such as fiber optics. Of course, if you're using copper cable, it is still considered very low, but not as low as the fiber optics. Okay, so because if you are using UTP, you are still using electrical signal to actually send your data, and all the electrical signal are subject to electrical interference, which is very common in our living environment. For example, you turn on your microwave oven, you turn your speaker very loud. So those are actually distortion that can cause error in data transmission. But fiber optics, because they do not use electrical signal, because they are using light, which is less influenced by electromagnetic interference. And the worst is wireless lah. Okay, a lot of you love wireless stuff, Wi-Fi, that of things, convenient. Yes, convenient, but the error rate is actually the highest among all the others type of transmission medium, because the wireless transmission is actually exposed. It is open. Any type of interference can just interfere the transmission easily. Okay, so how data being corrupted during transmission is all to do with interference lah. And then most of the time is electromagnetic interference lah. Usually electrical signals, wireless transmission is also greatly influenced by electromagnetic interference. So it will actually cause corruptions of your data, and it's actually corrupting the signals lah. When the signal is being corrupted, of course your 1 and 0 representation will be affected, and that is where the error start to occur. And of course, there are two different types of error here. So we have, if you're lucky, you get a single bit error. This means inside a group of data that you are sending, you only get 1 bit of error. Out of, let's say, 8 bits that you are sending, only 1 bit got errors. And if you are not lucky, you're going to get a burst of error. Okay, burst error, that means more than 1 bit. Multiple error happen inside a data stream. For example, you are sending 8 bits of data, maybe you get 3 or 4 bits that is experiencing error. So this is worst case scenario. The best case scenario is that single bits error. Right. And one good thing about errors that occurs in a digital system here is that all the data that you are sending is 1 and 0, you see. So if you know that that particular bit is got problem, is error, so it's very easy for you to correct it. If you know that this is bit number 4, okay, the bit number 4 is supposed to be 0, but what are you receiving? Let me draw a bit. Okay, let's say if this is bit number 4, they're supposed to be 0, but when you receive, you get this bit that is having error. But since you know that this bit got error, then you know how to correct it very easily. If it is not 1, it has to be 0. If it is not 0, it has to be 1. You only got 2 options. That's why to correct, when you experience a single bit error, and you know exactly which bit is actually experience error, then that is very easy for you to correct them. Change the 0 to 1, change 1 to 0. So this is how you can correct it. Okay, so it is not as sophisticated as what we have here. That's why a digital system is much more simple to deal with. But the problem gets worse when you have multiple error, such as burst error. When you burst error, you have too many errors, and that is actually much harder, much complicated for you to deal with. Unless you know exactly where are the errors, then you can still correct them. For example, if you know the location of the error, just like this one, if you know that this is bit number 4, bit number 4 has got error, then you can still correct it. That's why you have to first identify the location of the error before you can actually carry out the corrections. right? So this is an example of how you illustrate, burst error. So here you can see that you have multiple error here. You have 4 bits experiencing error. But if you can identify exactly which are the bits that experience error, you can still correct them. Okay? But the challenges is going to be, how do you identify the location of bits that experience error? How do you know? How do you check, you see? So this is actually the questions that is actually to be answered by the error detection technique that we're going to discuss later. Okay? So error detection, what's the difference with correction? Error detection is to see if there are any errors occur. If any error means as long as got error, that's good enough. You don't care where is the error. Right? So this is what we call error detection. But for error correction, if you want to carry out error correction, you need to know the exact number of bits that is corrupted and also the location. Okay? So there are 2 information that you have to identify. So this one is much more complicated. You need to know exactly how many bits is actually having errors and then where they are exactly. Okay? So this is required for error corrections technique in order to perform the correction. I know the correction is easy. If it is, if you know that that position is wrong, so now you detected 0, then you just change it to 1. If it is detected 1, then you just change it back to 0. Change it back to 0. As simple as that. But first, you have to know where they are and how many of them. Right. So this is actually how the detection and the correction works. So basically, you will have at the sender side, you will have your data over here, or this is the data that you wanted to send. So before you send it, so you do some magic, you do some calculation, okay, to create a redundant set of data out from this original data that you wanted to send. So you create this data redundancy, and you append it together with the data that you are with the original data. Then you send it into the transmission medium. So when the receiver receives the whole thing here, right, the receiver can use this blue color redundancy data to actually check, to do checking, you see, to do checking to see if this data is okay. So it's actually a reverse process. So something like if I actually send you a checklist, I want to send you a present, okay? I want to send you a box of present, let's say. In this box has got 5 items. This 5 items, then I put inside a list. I say item number 1 is what, item number 2 is what, item number 3 is what. So I attach this list together with the box. So when you receive this box, you just open up the box and you look at the checklist. Then you refer the checklist with the item inside the box. You just need to see whether they are correct. So if the checklist say got 5 items, but you only find 4 items, see, of course, there are errors, you see. So this is exactly the same concept that we're going to use here. We're going to use redundancy. And then this redundancy is actually additional information, which we can call it the checklist. It's something a checklist. But how are you going to produce this checklist? There are many different types of techniques, right? Because what you can deal with, what you can send here is only 1 and 0. So your data redundancy here, your redundancy has to be in 1 and 0 as well. See? So it is not a standard checklist that you can see, It is not ABC, That's why this is actually the challenging part, where your redundancy, the blue color redundancy that you're going to send, it has to be in 1 and 0 as well. So there must be some mathematics and some calculation for you to do that. And if you look at the overall pictures of this one, if you look at the physical layer here, the physical layer is only covering this one. Okay? This is actually the physical layer. Okay? The physical layer, we are using digital signal to represent 1 and 0, and this is what we call line coding. Okay? Line coding is actually using digital signal to represent 1 and 0. So this is 0, this is 1, this is 0, this is 1. Then at the layer 2, at the dealing layer, we have to use a different type of coding. Here we call it the block coding. So we apply different type of coding here to make sure that we can check we can actually check whether the data that we are sending has got errors or not. And then some of the more complicated block coding come with the features to actually correct the errors, right? Depending on which one are you using, which technique, which type of block coding are you using. Okay, so you have to be able to differentiate between physical layer and the data link layer. Okay, in the physical layer, we use line coding. The meaning of line coding is to use digital signal to represent 1 and 0. And then for block coding here, okay, it's only applied in data link layer. So this block coding has got many different examples, and its main function is to allow you to actually detect and correct the errors. All right, so for mathematics, it's all go back to the mathematics again. So we use the basic arithmetics for error correction and error detection, because after all, we are going to deal with 1 and 0 only, right? So when you're going to do, only can deal with 1 and 0. So what is the most effective technique is using this logic, using logic, or what we call the modular arithmetics, logic gates, that of thing. So you can see, okay, this is the example. For example, this one is using the exclusive OR. Okay. 0 exclusive OR with 0, you get a 0. Okay, I hope you still remember this. And 0 and 1, you get a 1. 1 and 0, you get a 1. Okay, so you look at this one. You look at this set. You see? So you can see the first set of data here is the one that you are sending. Okay, so you can use comparing two sets of data. The second set can be the one that you are receiving. Okay, so if actually see, they do not produce all the 0, that means there are some problems. Okay, there are some problems, some errors inside the two set of data. This is how you actually do the comparison. It's actually based on this very simple concept, because what we're dealing with is actually 1 and 0. So you can look at some of the example here. And block coding, the whole idea is actually you have two set of information. One is called the message, which is your original data that you want to send. And then the other one is called the redundancy data. And in this case, you can call it the parity bits. So you have two sets. And then what you are sending is the entire thing. This whole thing is the one that you are sending. Okay? So you have to send extra information. That's why it is called redundancy. Extra information needs to be sent across so that the receiver can make use of the redundant data to actually check for errors. Okay, you can look at this diagram here. Data word is your original data. Okay? Data word is your original data. So you will go through a generator, something like a calculator. So it will generate the code word. The code word is actually the one. Yeah, this whole thing is a code word. Code word is actually consists of your message bit and your redundant data. Here we call it the parity bits. So it's combined the two. Then we call it a code word. Okay, so you generate the code word. So once code word is being generated, it will be sent over. So errors will happen here. The error is going to happen here. And then when you actually receive at the receiver, so a receiver is going to have a checker. This checker is going to extract part of the code word, which is the redundant information, and then you're going to check it to see if there is error. So if there are error, your data packet will be discarded. The simple way to deal with error data packet is to discard the entire packet. Let the sender send one more time, you see. So that's the simplest way. You don't do anything, you just check. Got error, I just throw it away. Got error, throw away. Got error, throw away. Okay, until you receive one, there is no error, then you will extract the data word. Okay, so that is the simplest error detections in block coding. Okay, it's through the code word. Okay, so you can look at some of the example. So I will not go through the example here. So for detection, for error detection method, we will have three different types. the most basic three different types. Of course, the easiest is actually the first one, parity check. You just check for the parity. Okay, this is the simplest error checking, but it can only check for one single bit of error only. Multiple bit, it might not be efficient. So when you have a single bit error, you can use parity check. But who can guarantee that you always get single bit error, right? No one can guarantee. That's why you need something much more complicated, such as cyclic redundancy check, CRC, or even using a checksum. So these two are much more proper type of error detection methods. But of course, let's look at the easy one first, parity check. So parity check is just to check for the parity, whether the parity is correct or not. So either you choose either one, okay? Your system can choose either even parity or odd parity. It's up to you. You can choose one, but once you've chosen one, just stick to one of them. For example, you choose even parity, right? So when you choose even parity, let's look at this this one. Let's say if we are using even parity here, so this is the data that you are going to send. This is your message lah. The last one is your parity bits. You're going to append one parity bit. So you look at your message first. Count how many one. 1, 2, 3, 4. Okay, 4, 1. That is even. So if it is even and you are using even parity, then you just put a 0. Okay, so that the whole thing, so that the whole code word here, will be seen as even. Okay, even. So if you are using an odd parity, let's say, so you have to put a 1 instead of put a 0. So that the whole thing here is looked at odd. It will look as an odd. See? So it's actually very much straightforward. So whether you are choosing even parity, then you have to make sure the entire code word is even. So when you actually receive, this code word is being received by the receiver. So if the number has become suddenly changed to odd, then you know that there are errors. You see? There are errors happen inside, during the transmission that change one of the bits. And you know that there are errors. So if that happens, then you can just throw away the entire code word and then let the sender retransmit again. Okay. So for parity, okay, for parity check, it's very easy. You either choose one of them, even parity or odd parity. Right? So you look at the example here, then you will be able to know lah. So each of the word here, okay, each of the group here, each group has to be, this is actually using even parity. So you have to make sure the whole thing here is even. You see the blue color parity bit that is being added here. Okay, so is to make sure everything is even. This one even as well. This one even, and even. Right. So this is the simplest way. But the problem is this type of parity checkings can only check for single bit error. So if there are 2 bits error happen at the same time, and then at the end of the day, if you are choosing even parity, then even with 2 bits error happening, then it still show even parity. Then you cannot detect the errors, you see, because there's more than one errors that is disturbing. Okay? And you can even use 2-dimensional parity check as well. Okay, using row and column. So it's pretty much up to you. You can see this is how it is being implemented. So this is okay. This is actually the row. Okay, and then you can see this is your parity bits, and then you can even use this one. Okay, this is column. So this is your parity bits. So you can do a more sophisticated parity, 2-dimensional parity check as well if you want. Okay? So you will produce another set of code here. But the concept is actually similar. All right. So when you have more than one bit is experiencing error, so your parity checking may not be effective. So this is what I'm talking about. And you need to use a more sophisticated error detection technique such as CRC. So the CRC makes of much more complicated calculations, such as they use binary division, right, to actually produce the remainder, the CRC remainder, and then append that remainder at the end of the data unit. Then over the other end, they're going to do the reverse process to see if there is any let me see. Yeah, when you do the reverse, there shouldn't be any remainder at the end of the day. So if there are remainder, then the data is actually being corrupted. So again, I think the easiest way is for you to look at the example. It is easier. And I also included some of the additional video reference in Ellipse. You can click on the video. Those are the videos that I actually extracted from YouTube as well. I think they are quite good, quite simple for you to understand. Furthermore, they come with animations. So it is actually much more easy for you to actually follow as well. You know, which one move to which part, and then how this division is actually being carried out. The only issue, the only difference is that this CRC, how this redundant information is being generated, is actually based on the CRC method. So this is based on the division process to make sure that there's at the end of the day there is no remainder. Okay? So you use subtractions, and then I think it's easier to look at the example here. Okay? So this is actually you produce the remainder after the division, and then this remainder will be used as the redundancy, and then it will be append together with your message, and then they will form the code word. So it's again, you can see that this now. Last time when we use parity check, we only use 1 bit extra, isn't it? We only append 1 extra bit at the end of your data message. So your code word is just slightly longer, only slightly. But if you are using CRC, this is how many bits? 1, 2, 3, 4, 5, 6. You see 6 bits that you are sending, but you have to append another 3 extra bits to form the code word. So you can see the redundancy information that you are sending using CRC is much more, it's much more. That is going to make your overall transmission less efficient, because you have to transmit more redundancy bits, which is useless at the end of the day. You're going to throw them away after your layer 2. After you do error checking, you're going to throw away all those redundancy information. It will not be passed up to the higher layer. Okay, so at the receiver side, same thing. You do the division again. The result you should get 0. Your remainder should be 0. Then there is no error. If your remainder is not 0, it's not 0, 0, 0, then there will be errors. So something wrong if it is not 0. So this is a much more complicated one. And another way of detecting is using the checksum. See, checksum is another error detection technique that can be applied to any message of any length. So I think this is the advantage. So it is actually using the ones complement arithmetic. You still remember in your computer architecture, you have learned these ones complements. Now you know where they can be applied. You see. So one of the ways that you apply ones complement is actually in the checksum mechanism. So look at the example. I think it's easiest is to use those. The data is divided by k section of each of the n bits, and all sections are added using one complement. So you added using one complement to get the sum, and then the sum is complemented and become the checksum. Okay. So these are actually the step. So the receiver at the receiver end, it is actually just a reverse process. So the important thing is that if the result is 0, then the data is acceptable. Otherwise, it is rejected. So it has to be you're getting 0 at the end of the day. See? So look at the example. I think that will be very easy for you to understand through the example. That's why I say you cannot just look at the theory. The theory part sometimes can be quite confusing. That's why you really need to look at the example and look at the real example, and you will know. So this is a checksum that is being produced. And then this is going to be sent together, okay, with this block of information. So this is your redundant information. This part is your redundant information. Yeah. So if you want to look at a more animated type of explanation, I think I have included it inside our Ellipse video, additional video reference, the lowest at the lowest part after your mixed semester exam page. And so you're going to do the same. If you get all the 0 after the process at the receiver, then that means the thing is okay. Right. So those are on error detections. So we will have the easiest one, parity check, and we have the CRC, redundancy check, and we have the checksum. And the CRC and checksum are still very commonly used in a lot of systems. And now we look at error correction here. So error corrections means to correct the error, we have two methods. One is through retransmission. The other one is called through the forward error correction. So we call the FEC. FEC, when you hear the word FEC, that means that the correction is done at the receiver. Okay, forward error correction. It's not backward. And the retransmission is always the easiest, because you can always ask the sender to send one more time. You say got error, not acceptable, got error. So you do not want to send back the acknowledgement. So the sender is going to send one more time, right? Until there is no error, then you accept it. How about the second time when they send over still got error? Then you ask them to resend again. And then because of this many times of retransmission, that will actually slow down your overall network performance. That is the reason why your network is not performing well. And one of the way to avoid retransmission, because too many retransmission can cause slow network performance. So now you want to engage a forward error correction technique, FEC, so that error can be detected and corrected at the receiver. When you receive, you know there are errors, but you have the ability to correct them. And now we are going to do Hamming code. Okay, Hamming code is one of the, I would say, the entry level of error correction technique. And of course, we do not do the burst error corrections. So burst error correction will be much more complicated. We are not covered here. So we just get you to understand Hamming code, which is the simplest of error corrections. And yeah, so it's very much depending on the number of data bit that you are sending. So if you are sending 1 bit of data, then you need 2 bits of redundancy. You see, your redundancy now is more than your data. So the total is 1 plus 2, 3. You need to send 3 bits. So let's say if you are sending 6 bits of data, now your redundancy is only 4 bits. So total you need to send is 10. This means using Hamming code, it is good that you send more bits of data rather than sending the small number of bits of data. Because if you are sending small number of bits of data, your redundancy bit will be, your cost of redundancy is going to be too high, right? So if you look at this one, sending only 1 bit, you have to send 2 bit redundancy. Also, this is not worth it. Sending 2 bit, you also have to send 3 bit. This is higher than your number of data. Send 3 bit. Okay, this one become 3 equal. And now you're sending 4. Okay, this one still 3. 5. This one still remain at 4, which is lower now. So when you're sending 7 bit, this one sending only 4 bits of redundancy. So it is actually getting more efficient, I would say. Your transmission efficiency will increase as you send more bits of data when you use Hamming code. And this is actually the formula. But you don't really just look at the formula, you have to look at all the steps. Right? There are actually a series of steps that you really have to follow. So these are the bits of, this is how redundancy bits being inserted into the code word itself. You look at bit number 1 is reserved for redundancy, bit number 2 reserved for redundancy, bit number 4 also reserved for redundancy, and bit number 8, okay, and then later bit number 16, okay, and so on and so forth. Okay, so these are the blue color one is all the redundancy bits. Those are the bits that are actually redundancy data that is used to do the calculation, to do checking and to do corrections. And the step of creating the code words are as follow. So this one I will just leave it to the video. I mean, if you think that this slide or my lecture video do not explain it too clearly, then you can always refer to the additional video, like the additional video reference that I attach in Ellipse for further explanation. And these are the steps that you already have to follow. Okay, these are the steps. Position 1, position 2, position 3, position 8. So how are those redundancy bits being calculated? So these are actually following the step. So you just need to follow step. This is a series of steps that you have to follow for the calculation of Hamming code. That's why we only discuss the simplest. Hamming code is actually among the simplest for error corrections. That's why we do not want to discuss the burst error corrections. That's even harder. All right, I think this one you really have to do some hands-on, and then strictly follow this. These are the rules for different position. This is position number 1, position number 2, position number 4, position number 8. You know what is this 1, 2, 4, 8 coming from where? It's coming from here. Okay, 1, 2, 4, 8. And how about the rest? This D here, all the D here are your data. All the D are your data. So those are your data. Only the blue color one you have to calculate, because you need to calculate the code words to append together with your data and then to send it over. So you're just following all this step. So the easiest one we do until position number 8. Of course, when you have more data to send, you can go up to position number 16. The next one is 16, then followed by 32. Okay. So it starts from position 1, position 2, position 4, position 8, position 16, position 32, position 64, blah, blah, blah. Right. Okay, so I think that part I will just leave it for you to do the hands-on. You really have to do the hands-on. Otherwise, based on the example, you do the hands-on, then you will be able to see the beauty of this thing. All right, so there are some review here. Errors, we have single bit error, which is very easy to deal with, but most of the time you cannot know whether the number of error that your data is going to experience, whether it is single bit or a burst error. This is the part that you cannot tell. You cannot assume that always only got single bit errors. There's no such thing, because errors come in random. It's come through the interference, and you can never predict how much error you're going to get. And redundancy is one of the concepts for you to allow you to do checking on error. And then, of course, if you are using a more sophisticated technique, you can not only do the detection, but you can also do the correction as well. And then the common technique for error detection only is actually the parity check, CRC, and checksum. So this one can only check. After they check, they discover got error, they can throw it away. Then ask the sender to resend again. Go for retransmission. So if you don't want to do that, you can engage a more sophisticated technique such as Hamming code. Then you can perform the forward error correction, FEC. So using Hamming code, they can go through a series of complex calculation. Then you'll be able to pinpoint which other location has got error. Then you can correct them. Okay, it's very much Hamming code is very much to determine the location of the error bit. Which bit has got error, exactly where it is. Once you can pinpoint it, then you can fix the error. Because fixing error is easy. If it is not 0, it has to be 1. If it is not 1, it has to be 0. So that's why we love about digital transmission. For error correction, it's very easy. Analog system, you can never do that. Analog system come with any values, so you cannot tell, what kind of value. It is very even harder for you to do error correction on an analog system. So a digital system to do error correction is easier, much easier as compared to an analog system. That's why this whole world here, people love digital system. Very easy for error correction. Okay, I think the rest are all the example. So, yep, I think we have done some of the important discussion. Some of the important discussion here on the what do you call the data, the error correction control. So I hope you get the overall concept, meaning to say that, you know, if a layer 2 is actually the first layer that you start to check for errors. Okay, so when you be able to check for errors, then you can tell whether you want to accept it, or you want to correct it, or you want to throw it away, then asking for retransmission. So this is actually the first layer, start doing error checking. Of course, some of the higher, the higher layers also do error checking as well. But you know that each of the layers are actually independent. So because of they are independent, so they will do your own error checking. So error checking could be carried out multiple times at different layers. So if you look at data link layer, this is how the data link layer is doing it. So it's going to be using these are the technique. Okay? These are the technique that is going to use for error checking and error corrections. And please bear in mind that if you are engaging a more sophisticated error detection and error correction techniques, then the CPU power, you're going to consume a lot more CPU power as compared to some of the simple one. The simple one do not consume too much CPU power. So if your computer already very slow, then you don't want to engage such a complicated, technique that will consume too much of your CPU power. That's why some of the low performance computing device, they do not engage complicated type of technique because it consumes CPU power. All right, any questions? Are you all happy?
So far, okay, I think.
Yeah, all right. So when you, there are actually some of the reference video, that I put in ellipse. These are 3 additional video that I put in ellipse. You can also refer to some of these videos. Sometimes you really need to have someone show you the animation on how this works and all those things. So it will be easier for you to catch up. Sometimes for me to explain using words, using verbal can be quite difficult for you to follow. That's why I would really appreciate some of these people that create some of this animated video to illustrate how the technique works. So they will really help you to understand better. Right, so make good use of those videos. I already posted. It's not me created one. Okay, it's actually I extract it from YouTube. I just make your life easy, so I just repost it there. I just cut the part that is relevant, and then I put it there, so that you can take a look. Okay.
Okay, thank you, sir.
All right, thank you. So, yeah.
Can you explain about our project?
All right, your project is a group project again. Okay, I know some of your group member last time may have problem. Okay, if you have problem with your group member, some of the group member who are actually really not active in your group participation. So I mean, if your group member or your group member cannot stand you, then if they make a complaint again, then you might be in troubles lah. So make sure that you actually participate. So for that group project, you are required to study the requirement. I actually gave you the diagram of the building. There are actually got 3 offices. This company has got 3 offices in 3 different buildings, but in the same area, not too far away. You can see from the diagram of the location of the building. I also attach you the layout, the office layout of the 3 offices. So now, if you study the number of users, and then based on the requirement, what are the purpose of the network and all the stuff, so you need to design a network. You need to design a network to link all the 3 offices together, because the requirement said that you only allowed to have just one internet gateway, because the company want to save money, right? So they only subscribe to one internet gateway. But of course, they also want the other office to be able to make use of the same internet gateway. And then there are some, different number of employees in each of the offices. You're going to link them together. So what kind of network are you going to lay? So how are you going to interlink different offices? So how about the internal network for each of the office? Okay. So what are the different type of network that is suitable? So those are the things that you have to discuss, right? You have to discuss. So then you come up with a proposal, basically a proposal. You draw the network diagram, and then you identify which are the network component, network equipment that you're going to use, what kind of network technology, and so that you illustrate how are you going to provision network for this company, and then why. Of course, like inside your report, you have to say why. Why are you doing so? Why are you doing this and that? So what is your justification of using this side of technology? Why is your justification using this kind of network? So those are actually the project, right? You can always ask question again along the way. I mean, if you still find that certain part is still not clear, you can always ask question inside our group, right? So I can explain further. But this is actually the basic requirement of this project, meaning to say you have to study the requirement of this company, and then you have to come up with a network, propose a network. Okay, is that clear? I hope it is not too difficult for you. This is a new question. Previously, they were doing a slightly different questions. So we need to change the question from time to time now. Okay, so I think along the way, if you have questions, you just ask again. Let's say a certain part is not clear, then I can always explain further. For some of you who haven't started your discussion, then you better get it started. And for some of the members who are previously not active, you will always advise to be active. Okay? Any more questions?
Thank you, sir.
Yeah. Okay, so I mean, if you have scanned your attendance, then I think that's it for today. Thank you very much.
Thank you, sir.
Yeah, you may leave after that. Thank you.